This video is a guide to the concept of work done by a force. So in the image on screen we have a person pushing a box. They're applying a force F and they are pushing the box over a distance d. Now you may notice that the F and the D both have arrows above them. I've added these to indicate that they are vector quantities. Now what that means is that their magnitude and direction is important. So it's important that the force and the distance moved are in the same direction as one another. If they are not, we cannot use that information to calculate the work done. So let's take a look at the equation. We have that the work done is equal to F times D, where F is the force and D is the distance moved in the direction of that force. So here's the key point. The distance moved is the same direction as the direction that the force is applied. Remembering that work done is measured in joules because it's energy, force is measured in newtons, and distance is measured in meters. Now you may also see this equation written in this way, where W equals F times S. In this case, F is the force and S is what's called the displacement. Displacement is the vector version of distance. Distance is usually just a magnitude. However, displacement is both how far you've travelled and what direction you've travelled in. So let's look at how we can use these. If we have a person pushing a box 4 meters with a constant force of 10 newtons, calculate the work done by that person. So what we do is we write our equation down first. Work done equals force times distance. Then we simply replace the F with the force. We can work out which one the force is because the force is always measured in newtons, so we have 10N. And the distance we can work out because it says M for meters. So we now have 10 newtons times 4 meters. So our work done in this case is 40 joules. Next, a person lifts a box weighing 20 newtons up to a height of 50 centimeters. Calculate the work done by this person. Now remembering that distance must always be measured in meters, we have the height in centimeters. So we need to do something here. We need to convert from centimeters to meters. So we know that 100 centimeters is 1 meter. So therefore 50 centimeters must be half a meter, 0.5 meters. Again, we can write down our equation and we simply replace the numbers. So we now have 20 newtons times 0.5 meters. This gives us a work done of 10 joules. Now it's important here to note that the box has a weight. Weight is a force which acts downwards. The height is a direction which is up and down, and so we can use it to calculate the work done. However, if the question had said that the box weighs 20 newtons and a man walks a distance of 30 meters, we could no longer calculate the work done because the man has not lifted or dropped the box. The distance moved is not in the same direction as the force applied. Finally, a car travelling at 50 meters per second applies the brakes. The brakes apply a force of 50 kilonewtons and the car comes to a full stop in 20 meters. Calculate the work done by the brakes. In this case, we've got 3 different numbers and we need to know which ones to use. Well, we know that work done is force times distance, so this time we must use the force of 50 kilonewtons and the distance of 20 meters. The 50 meters per second does not help us solve this calculation. So first of all, we need to make a conversion. We know that 1 kilonewton is equal to 1,000 newtons, so if we have 50 kilonewtons in the question, that's 50,000 newtons. Then we write our equation, work done equals force times distance. We replace the letters with the numbers, so we have 50,000 times by 20, and that gives us a work done of 1 million joules. We can then use another conversion. Since 1 million joules is 1 megajoule, we can say that the work done is 1 megajoule.